In this lesson, we're going to cover Unit 6, Acquisition 3 on 3-step stoichiometry conversions. So before we get to the example problems, I just want to do a quick review of the types of conversions that we've already talked about and the conversion factor that you would use. So first, we can convert between grams and moles. And again, it can go either way, whether you're starting with moles and solving for grams, or if you're starting with grams and solving for moles. The conversion factor that you would use is the molar mass that we would calculate using the masses found on our periodic table. We could also convert between particles and moles. And again, particles could be molecules, atoms, ions. And in that case, we would use Avogadro's number. 6.022 times 10 to the 23rd molecules per mole. And then lastly, if you were trying to convert from moles of one substance to moles of a second substance. Let's say we have moles of a reactant and we want to know how many moles of a product we can form. We would use that mole ratio. So those are the three conversions that we are going to be putting together today. First example. How many molecules of aluminum chloride can be produced from 10.6 grams of magnesium chloride. And then we need a balanced reaction. 3 moles of magnesium chloride plus 2 moles of aluminum yields 3 moles of magnesium plus 2 moles of aluminum chloride. The balanced reaction will be given to you, so everything in the question in black would be given to you. So what we want to do when we're approaching this problem is we want to look at the given and we want to look at what we're solving for. So I'm starting with grams of magnesium chloride. I'm solving for molecules of aluminum chloride. So I know I'm starting with grams. I know I'm solving for molecules. I know I have one substance and a second substance, so we're going to need a mole ratio. We always start with the given. We are given 10.6 grams magnesium chloride. Remember, when we're setting up our conversions, you should have 3 things: a number, a unit, and a substance. So looking at the little cheat sheet we made at the start, I'm starting with grams. The only thing I can do if I have grams is solve for moles by using the molar mass. In this case, they gave you the molar mass. Remember, we need the unit and the substance to cancel. So that means grams of magnesium chloride must be in the denominator. And there are 95.21 grams for every 1 mole of magnesium chloride. Grams divided by grams would cancel. So now I'm at moles of magnesium chloride, but I need molecules of aluminum chloride. So I have moles of one substance, I need to convert to a different substance. Mole to mole is going to be the mole ratio. Again, we need both the unit and the substance to cancel. That means moles of magnesium chloride will go in the denominator, and I find that out using my balanced reaction. Whatever you're solving for always goes in the numerator. 2 moles aluminum chloride. Moles of magnesium chloride divided by moles of magnesium chloride will cancel out. So now I'm at moles of aluminum chloride. All of my other units canceled out. So I'm at moles, and I need to get to molecules, which is a particle. So if I'm going from moles to particles, I use Avogadro's number. In every 1 mole of aluminum chloride, there are 6.022 times 10 to the 23rd molecules of aluminum chloride. So again, moles divided by moles will cancel, and the units we're going to be left with are molecules. Let's go over again how we would put this in our calculator. We would multiply everything across the top. If you're doing one big calculation, make sure you use parentheses. 10.6 times 1 times 2 times 6.022 E23, end your parenthesis, divided by, on the bottom, 95.21 times 3 times 1, and I get 4.4696 times 10 to the 22nd. We always want to think about significant figures. My given has 1, 2, 3 significant figures. So my answer needs to have 1, 2, 3 significant figures. Don't forget your times 10 to the 22nd. Molecules. So final answer, 4.47 times 10 to the 22nd molecules. So let's do one more, and we're going to go the opposite way. So this one, we went grams to moles to moles to molecules. This time, let's start with molecules. How many grams of iron are needed to completely react with 4.2 times 10 to the 24th molecules of oxygen. All right, so for this problem, we have a certain amount of oxygen, and we want to know how many grams of iron are needed to completely react with all of the oxygen. It's like saying 2 pieces of bread plus 1 piece of cheese makes a grilled cheese sandwich. If I have 8 pieces of bread, how many pieces of cheese do I need to make all of our sandwiches to use up all of that bread? So any type of problem, again, whether it's 1 step, 2 step, 3 steps, we always start with a given, and we should include 3 things. First, the value. 4.2 times 10 to the 24th. You should have the units, molecules, and the substance, O2. We're starting with molecules. Use the cheat sheet if we need it. If I'm starting with molecules, the only thing I can do is convert to moles by plugging in Avogadro's number. 6.022 times 10 to the 23rd molecules of oxygen in every 1 mole of oxygen. Molecules divided by molecules cancel, and we're left with moles. I'm at moles of oxygen, but I need grams of iron. I'm starting with oxygen, solving for iron. I have 2 different substances, so we need a mole ratio. Both the unit and the substance have to cancel. So moles of oxygen will go in the denominator, and based on my balanced reaction, I have 3 of them. Whatever you're solving for goes in the numerator. I'm solving for iron. I have 4 moles of iron. Moles of oxygen divided by moles of oxygen cancel. Lastly, I'm at moles of iron, but I need grams of iron. If I'm going from moles to grams, I need the molar mass. This one doesn't give me the molar mass, but I can find it on the periodic table. Iron is 55.85. In every 1 mole of iron, there are 55.85 grams. Last step is our calculation. Again, we want to multiply everything across the top. 4.2 second E24. Again, no times, no 10, no caret. 4.2 times 10 to the 24th would be 4.2 E24. Times 1 times 4 times 55.85. And then I'm going to divide that by the denominator. 6.022 E23 times 3 times 1. 519.36. Lastly, let's round to the appropriate number of significant figures. 4.2 has 2 significant figures, so this would round up. And again, we need to put in a 0 as a placeholder. If I owed you $519 and said, here's $52, it's the same thing, I rounded, you're probably not going to be too happy. So the way that we can round this number and only have 2 significant figures is by putting a 0 in here. As long as we don't have a decimal, this trailing 0 is not considered significant. So this has 2 significant figures, and 520 is much closer to 519. And then lastly, we need units. How many grams of iron are needed? 520 grams.